All right, hey everyone. We'll first go through a quick Hangouts on Air 101 so that we can make this a bit more interactive. So if you can see your screen, there's on the left hand side, there's a Q&A, there's a message, a chat thing, and there's a showcase option. The Q&A is for asking questions. If you guys want to talk or chat during the Hangout on Air, you can use the chat menu. Uh, if I feel the need to share any links, those will be shared on the showcase. All right. Now I'm going to start the presentation. Uh, I'll share the link for the presentation so that in case you want. Okay, so if you go to showcase, the link of the presentation is already shared. I look at Bluetooth Low Energy. If you guys want to follow it on your own, you can follow that link. Otherwise, I'll be showing it here anyways. All right. So we're going to begin with the presentation now. Uh, This presentation is going to be about Bluetooth Low Energy as a technology. What are the support systems for Bluetooth Low Energy on smartphones? What are the different microcontrollers, microchips, ICs that are available which utilize this? A brief history about Bluetooth Low Energy. We're also going to take a look at the architecture. What are the terms that are used while defining the technology stack that's there for Bluetooth Low Energy, etc. So let's start with the history of Bluetooth. So Bluetooth is a licensing organization, so to speak. Bluetooth as a technology was initially developed at a company called CSR. Robin Hayden was one of the co-chairs of the Bluetooth special interest group. What happened is Robin Hayden joined CSR, which was a small startup back in 2000, and they were working on mesh networks. So Bluetooth was relatively new then. After that, they started working on a project called as Wibree, spelled as WIBREE, and that was eventually formalized and taken to Bluetooth, and that became a standard. So Robin Hayden is primarily given credit for Bluetooth Low Energy as a stack, but there were a lot of people involved in taking it the last mile, which was the standardization using the Bluetooth trademark. So when it was conceptualized at CSR, Bluetooth Low Energy was not thought of as an uh, upgrade for the Bluetooth Classic, which was pretty predominant, but it was thought of as a new way of doing things, primarily to fit the need of coin cell batteries to power up things. So everything that has been conceptualized in Bluetooth Low Energy is based on the fundamental requirement that it should be run off battery cells, button cells, sorry, the CR2032 button cells that which we commonly find in our watches, etc. So that's the primary requirement for Bluetooth Low Energy. Everything else, how it accesses memory, what are its frequency hopping algorithms, what are the application level protocols that will be available. Everything was modeled based on that fact. So let's take a look at the architecture. Okay, before that, let's see what Bluetooth Low Energy can't do. So Bluetooth Low Energy cannot work on the same hardware as Bluetooth Classic. So this requires a major upgrade. as all the smartphones, all the normal Nokia phones and the ones that we had before smartphones, all the headsets, all of those are incompatible with this new stack. So even if we have a method of upgrading the firmware on all of this hardware, we won't be able to use the features that Bluetooth Low Energy offers. So that's one important factor, and that's predominantly seen in Android because Android phones typically have not been upgraded with Bluetooth Low Energy because there are so many original equipment manufacturers for those. Uh, that's why it takes a lot of time for Bluetooth Low Energy to reflect in terms of hardware in the whole Android ecosystem. Whereas Apple has had it since iPhone 4S. Apart from that, a Bluetooth Low Energy chip cannot have high bandwidth. So it won't be capable of transmitting audio, which was one of the biggest feature in the classic Bluetooth. People used to use Bluetooth headsets, right? So that was one of the biggest trade-off that the Bluetooth Low Energy guys had to deal with, that they could not transmit Bluetooth audio. So Bluetooth Low Energy, if you take a look at it, is not meant to replace Bluetooth Classic. It's meant to complement Bluetooth Classic. What BLE can do, and this can be done very well with Bluetooth Low Energy, is it can do indoor positioning. So what it means is Bluetooth Low Energy, the killer application for Bluetooth Low Energy will probably be indoor positioning, as that opens up a whole new bunch of applications and domains. And the most important thing, the fundamental requirement for Bluetooth Low Energy is that it should last at least a couple of months on coin cell batteries. So these are the things that Bluetooth Low Energy can do very well. Now let's take a look at the architecture for Bluetooth Low Energy. We're not going to take a look at a comparative architecture between Bluetooth Low Energy and Bluetooth Classic, because Bluetooth Classic was primarily based on the TCP/IP stack. So the methods of communication, etc., were very similar to the way we interacted with on the internet. Whereas on the Bluetooth Low Energy thing, we have a completely different kind of things. Some of the things are very similar, like profiles. We had profiles for audio, memory storage, etc. Black and Bluetooth Classic. We have similar things here. So the generic access profile in the host layer is used as a metadata kind of a thing. So what we have in generic access profile is 5 services, which basically tell me information about the device, the signal strength, etc. So it will have at the most 5 services in it. The generic attribute profile, which we call the GATT, that's something that will run across many times when taking a look at the source code for apps or the libraries that are available for iOS and Android, etc. So the GATT profile is the place where all the data exchange and all the logic lies. Apart from that, an interesting thing is the host controller interface, which allows us to wirelessly connect and debug the hardware. So this is something that was added to Bluetooth Low Energy after Bluetooth Classic, because that need was felt with Bluetooth Classic hardware. So that's why the host controller interface in turn enables the direct touch mode in the controller layer. Right, now we're going to take a further look at the architecture. So if we take a look at this, we can divide the hierarchy of the architecture into a couple of things. The main aspect is profiles. Profile can consist of multiple services. Multiple services will be classified based on the job, the function that they do. So for example, let's say we have a heart sensor profile. In that case, one service will give us the device information, while the other service will give us information about the actual heartbeat. So the profile will be for heart sensing, but it will be divided into multiple services. What each service has is one or more characteristics. So each characteristic, just like each service, will have its own unique UUID, which is a unique identification thing. What we have to do is we can basically connect to a particular characteristic from another device using the UUID, or we can scan for all the services select one service and scan for all the characteristics in that, right? So the characteristic, for example, in the heart sensing application can be the beats per minute, right? So the beats per minute value is going to be the characteristic value, and the descriptor is usually something like the unit. So for example, instead of the heart sensing one, we had a temperature service, a profile for a temperature sensor, and a service which gave the value for the temperature. The descriptor would have a degree Celsius or degree Fahrenheit as the data in it, right? So now the profile is something which is fixed. We can change that by changing the firmware. So a particular hardware will usually not be able to change the profile on the go, right? The next thing that we're going to take a look at is some of the profiles that are there in Bluetooth Low Energy. So the heart rate profile, if you can see, HRP is the one which is already incorporated. That was the example that we were talking about before. So the heart rate profile will be the one in blue here. The services that will be there inside the heart rate profile will be HRS, the heart rate service, as well as the device information service, the DIS. So those two will be the yellow services, and the beats per minute value will be the value in one of the characteristics, for example. So these are the current profiles that were supported in Bluetooth 4.0. There have been some upgrades to the supported profiles, and the Bluetooth special interest group has been very open about adding new profiles every couple of months. So recently they released another set of new profiles. We'll take a look at that in some time. But these are the profiles that were released as the initial version. Also, they are open to new profiles being contributed by chip manufacturers and end product application developers. So one of the important applications of Bluetooth Low Energy has been beacons. So Apple in 2011 licensed the term iBeacon. So this term was licensed so that they could write their own abstraction layer on top of the Bluetooth Low Energy hardware. And what they could do is they could create a certification program for creating hardware which is iBeacon compatible. So this is something which Apple usually does. This happened with the creation of iPod and made for iPod hardware too. So Apple will basically license out their certification for a fixed amount if you want to make devices that are certified to work with iOS devices. So iBeacon devices, iBeacon being a trademark of Apple, will be licensed to work with all Apple devices. But the format that they use, the packet format, is open. So any other device which has Bluetooth Low Energy support, Android for example, will also be able to work on the iBeacon protocol. So let's take a look at the packet format which the iBeacon protocol does, because this is something very interesting. There is no kind of two-way communication in the iBeacon format. So the best analogy to explain a beacon is a lighthouse. A lighthouse is consistently emitting lights in a lamp in all directions, but it does not take feedback from the ships that it guides. So the lighthouse is basically the beacon, and what it does at fixed intervals, it will broadcast a packet. That packet is unique in some ways. That format is the one which has been licensed by Apple, so only iBeacon compatible devices are supposed to use that format. So for example, the fixed header will identify that the packet that is to be followed is going to be an iBeacon packet. Right, so just a minor interruption. If anyone wants to interrupt with any questions, please do that. To do that, you can go to the Hangout on Air thing, and there's a Q&A section on the right, on the left, sorry. So if you can click that, you'll be able to ask any kind of questions. Right. So one question from Pratik Chaudhary. The maximum number of profiles that you can have uh, is not kind of, so I'm currently answering this, 1 second. Yeah, the question asked by Pratik Chaudhary is what's the maximum number of profiles that I can have? So profiles are basically something which is meant for the smartphone to understand. So a typical hardware, so let's say I have a health band which measures the heart rate sensor, that is going to have only one profile, let's say, and my smartphone will be able to understand that profile because it follows a particular standard defined by the Bluetooth guys, right? So that hardware can have multiple profiles doing multiple functions, but each profile will be independent and it will have a standard format. So one function can be the heart rate sensing. Let's say I'll have another function doing the temperature sensing, but that will be completely independent both on the hardware as well as on the smartphone side. That will be run as two different profiles. Right. So we'll come back to the iBeacon packet format that we were going through. So the iBeacon packet format has four things that we have to take a look at. One is the Apple-defined prefix, which identifies that it's an iBeacon packet. The second is the UUID, which is set by the developer. The third and the fourth things are the major and the minors. These are the things which are used by the developer to transmit some kind of information. So let's say if I set the major as 2 and the minor as 3, that would mean that the user who just received this packet is on floor 2 next to the room number 3. So if I want to transmit some kind of information as floor numbers and room numbers, I'll use the major and the minor. The proximity UUID will be used to identify which device I'm getting the packet from. So I'll probably read the UUID, talk to a RESTful API or something and ask that on the application end as to what exactly this signifies. And the fixed header will basically start this whole process by identifying that the packet that I just received is an iBeacon packet. So the applications for iBeacon are the most interesting ones. So indoor positioning. So basically you are using a couple of iBeacons, or by using the major and the minor values of iBeacons, I can basically know where exactly I am inside a building. So where GPS ends, the limitations of the GPS are that it probably won't work inside a large building. So inside that, I'll use an iBeacon deployment to know exactly where I am within sub-meter. So that means I'll get centimeter level accuracy for indoor navigation. Indoor positioning, sorry. So indoor positioning is basically me knowing where exactly I'm in a building. That gives me some other interesting applications. So navigation for one. So let's say I'm in a super mall. I'll be able to navigate the super mall because I know exactly where I am in that mall. So let's say I'm in the book section and I want to go to the jeans section after that. Using iBeacons deployed in the super mall, I can basically navigate there. Contextual notifications is another interesting application of iBeacons. So what I can do is, let's say I walk into a store and I'm only interested in jeans right now because that's what I want to buy. So I spend a lot of time in the jeans section and some time in the t-shirt section, but I find out the jeans to be a bit expensive. So I decide to start walking away from the store. That's when the store, which has iBeacons deployed, will realize that I spent a lot of time in the jeans section and I'm going out without actually buying anything. So they can give me a custom notification on my phone, assuming that I have their app installed, saying that there's a special discount for me on the jeans section, right? So this is a contextual notification. This is contextual because they identified what was the context of the user, which was me, and the context was I wanted jeans and not shirts. And they decided to give me a notification, which was a special discount, just because of tracking me inside that store. So this is again an application of indoor positioning done using iBeacons. So iBeacon SDK was launched 2 odd years ago, and recently Apple announced Apple Pay, which is based on the NFC, which is RFIDs. So Apple Pay will be implemented in complement to iBeacons. So the payment aspect will happen using NFC, but where I am and what I just bought, etc., will be stored using iBeacons, right? So NFCs and Bluetooth Low Energy, these things will go hand in hand, according to Apple, for taking forward the Apple Pay thing. So one of the major companies that has banked on the whole iBeacon technology is STMode, and a lot of startups have started using STMode beacons and iBeacons in general to create custom solutions based on indoor navigation. So one of them is baseball stadiums. So a lot of stadiums have already deployed beacons, which help people to navigate to their seats, which help people to find food stalls. Shopping malls have started to implement beacons. There are two startups who have started to take orders based on iBeacon. So these startups are Cover Downtown, and there's one called Blink, which is dealing only with nightclubs, which are enhancing the experience of users who are in restaurants or nightclubs using iBeacons. So this is again something which is very interesting. An interesting aspect of Bluetooth Low Energy, because iBeacons is only one profile, there are plenty more. So now we'll take a look at iOS and Android and the support that they're offering based on Bluetooth Low Energy. So iOS devices have had an amazing kind of support for Bluetooth Low Energy, whereas Android is still catching up. The latest release for Android, which still accounts to a very small fraction of the devices that are out in the market, the latest Lollipop, as I was saying, has the best support for Bluetooth Low Energy. It supports Bluetooth as a central and Bluetooth as a peripheral, which was not there in the previous versions. Also, the scanning aspects of Android and Bluetooth Low Energy have improved in the last upgrade. There was a serious bug in the previous section, in the previous version, sorry, of Android, in which when there were too many devices in the vicinity of an Android phone, the app used to crash. So that has been fixed in Android 5.0. That was a major headache for app developers, but now in the latest release of the API, it has been fixed. So hardware-wise, all the iOS devices after iPhone 4S have the required hardware. The iPad 3rd generation, iPad mini or later, and the iPod Touch 5th generation or later have the required hardware which is used. So the biggest application is, of course, the iPhones. Whereas in Android, lately almost all the devices have support for Bluetooth Low Energy. Any device which is running Android 4.3, anything before Android 4.3 will not support Bluetooth Low Energy. Even if a device is running something after Android 4.3, it is not a given fact that it will support Bluetooth Low Energy, because it requires additional hardware, which it may or may not have. But any device which has roughly released after 2013 will have support for Bluetooth Low Energy in the software as well as the hardware aspect. So the next thing that we're going to take a look at is some of the chip makers who are making the Bluetooth Low Energy hardware, which is used in the smartphones as well as outside of smartphones to create peripherals. So the first one is TI, Texas Instrument. So they were the second people to come out with a Bluetooth Low Energy chip. There was the CC2540. So all the links on this particular slide are clickable. So if I click on a particular one, it will take me to a new page, which will have the detailed information of that particular part. So yeah, coming back to CC2540. CC2540 was the first chip in the CC254X series from Texas Instrument, which is single band Bluetooth low energy devices. Why I say single band is because you can have dual band, which means that it will support the older version of Bluetooth as well as the newer version, the Bluetooth 4.0. So these are purely single band, purely Bluetooth low energy enabled devices. So the CC2540 was released initially, and it had support for full USB 2 specifications. So I could connect it directly to a USB port, so to speak. The next version which they launched was the CC2541. They replaced the USB functionality as they realized that not many people were using it, and replaced it with I2C or I2C as it's commonly known. The current requirements are interesting here. The CC2541 basically runs on 14 milliamps while transmitting and receiving, which is the low energy aspect of Bluetooth. The next manufacturer that we're going to take a look at is Nordic. So Nordic, most of the maker community or the developer people are banking on Nordic. Estimate themselves are using Texas Instrument, but a lot of new developer boards have started using Nordic. There are a couple of reasons for that. We'll go into them. So these are the four system on chips and ICs which are available from Nordic for Bluetooth low energy. The first two are system on chips. That means that they are very well packaged, and the IC, the Bluetooth low energy IC, is not the only aspect of it. They have something else known as the programmable peripheral interconnect, which allows them to connect to a multitude of sensors and get that data and provide that data over Bluetooth low energy. The third and fourth are pure ICs, and you have to take care of designing the whole circuit so that you can connect such sensors or a microcontroller or something on those lines for this. The first two, the system on chips, NRF 51822 and 51422, they're built around 32-bit ARM Cortex CPUs, plus the integrated chip, which will be the Bluetooth low energy. So these are the most used ones right now in the developer community because they allow, with the programmable peripheral interconnect, to upload firmware over the air. Right. So the next thing that we're going to take a look at is Broadcom. Broadcom entered the whole Bluetooth low energy segment quite late as compared to Texas and Nordic. So they have plenty of modules which mix the older Bluetooth with the Bluetooth low energy. But these two ones are the only ones which are single band, and they have purely Bluetooth low energy support. So they built a small sensor which has 5 environmental sensors and used the BCM20737S to create a small module for it. We'll go into the details in the next slide. Some other companies who are also invested in Bluetooth low energy are Atmel, Marvell, and Blue Giga. Blue Giga was actually the first company to come out with a Bluetooth low energy chip after the standard was announced. So Atmel is the latest addition to someone who started dabbling in Bluetooth low energy. Before this, they didn't really have their own Bluetooth IC, but in July 2014, last year, they acquired a company called Newport Media, and now they've started developing Bluetooth low energy chips. So these are the main manufacturers who are providing Bluetooth ICs. But if you take a look at Alibaba or AliExpress, there are a lot many modules which come with certification, which are very easy to use by exploiting the serial interface, etc. So the next thing that we're going to take a look at are some of the developer boards and kits which are available to get started for application developers. So basically, these are very easy to use, ready-made consumer grade hardware, especially the kits one, which have some sensors and some other things incorporated in it already, so that we can begin development of software as soon as possible. So if you take a look at the kits first, the sensor tag from Texas Instrument was the most popular one. They released open source iOS and Android apps to start playing with the sensor tag. And it had a couple of sensors like the temperature sensor, an accelerometer, a pressure sensor, etc. on the sensor tag. The Wicked, that's how it's pronounced, is from Broadcom, and it consists of 5 environmental sensor along with the 737S IC from Broadcom. Nordic surprisingly has a lot more boards and SDKs available than anyone else. So they have plenty of apps in the Play Store as well as the App Store. They have the Nordic Developer Kit, which is basically the Bluetooth IC along with some other peripherals which can be connected via USB to your computer, and you can begin development. Some of the other development boards are basically a combination of one of these ICs from either Texas or Nordic or Broadcom, and another Atmel or similar microcontroller, which gives it Arduino compatibility. So TA, which is a product by Revealing Our Creations, is one of them. RFduino was one of the first ones to do something like this. The red board, the light blue bean, Bleeduino, Blue Fruit by Adafruit, and Nordic Puck are some of the other boards. So each of them has a unique set of features. Comparing all of them is probably a different hangout on era altogether, but these are the ones that are commonly available right now. After this, we're going to take a look at TA, which is something that we have been working on Revealing Our Creations. We did a crowdfunding campaign for it, and we are in the middle of shipping this board. So the TA is basically, we have a module which consists of the Texas 2541 and a microcontroller from Atmel, the 32U4, which is also found on the Arduino Leonardo. So this is how the TA looks. This is our final version that we will be shipping to our backers in the next 2 weeks. So if you take a look at it, it has an onboard USB, which makes wires redundant. You can directly plug it in to your USB port and start programming. It has dual inline parallel ports, parallel pin headers for all the analog and digital pins. The antenna is conveniently located at the very end so that it maximizes the range. In fact, it's not visible in this photo, but on the back side there are no electrical wires, which increases the range of the antenna to almost. We tested it in a straight line, and it was almost 150 feet, which is excellent. So now we are going to take a look at some of the other aspects of Bluetooth Low Energy, which have been recently released in some of in 2 upgrades. So one of the upgrades was was announced in December last year, and that took the Bluetooth Low Energy from 4.0 to 4.1. So in this update, there were a couple of things that were changed. 2 of the main highlights of this was the reconnection timeout interval. So let's say I'm connected to some Bluetooth device, and I disconnect and I want to connect to another, or let's say I want to reconnect to the same device. So the interval that was there between this was hard-coded. It was not, as a developer, I would have not been able to change that. But after 4.1, after the 4.1 update, I can set that timeout myself. The other one, which is very interesting, is that Bluetooth Low Energy can be used to create networks. So in that case, let's say I have a network which acts like a hub, and I have a hardware. Let's say I have a piece of Bluetooth Low Energy which acts like a hub, and I have another piece of Bluetooth Low Energy hardware which acts as an endpoint. Right, so the hub is going to receive packet and then transmit it to the endpoint. So now these modes could not be set during runtime in Bluetooth 4.0, but after 4.1, I can dynamically change between acting as a hub and acting as an endpoint. So this is one major thing which is slowly taking the Bluetooth Low Energy standard to a mesh kind of a topology. The second upgrade was announced very recently. It was actually announced last week, and that introduced some very new and sought after features. One of them was IPSP. So if we take a look at Bluetooth Low Energy, the way it works is very different from TCP/IP or the old Bluetooth Classic. So what people were longing for is a way to bring in Bluetooth Low Energy into the whole Internet of Things domain by making it more internet-like. So the IPSP profile, which stands for IP specific profile, not exactly sure about that, but yeah, takes this idea forward. So now I can basically have Bluetooth Low Energy hardware accept packets the same way that packets are accepted on the internet. This was not possible in 4.0 and 4.1, but after the 4.2 update, this will be possible. Another interesting aspect was addition of privacy features. There were a lot of concerns that the UUID can be changed, so we can have spoofing done very easily. And a lot of people had published interesting blog posts about how they spoofed a particular iBeacon which was deployed in a particular mall by using similar hardware. So those features have been taken care of. Those bugs, so to speak, have been taken care of by adding some new privacy features. So I'm technically at the end of my presentation. I'm now going to take a look at some of the questions. Yeah, so the first question that I see here is how many BLE devices can I connect to at one point of time? So this is an interesting question. So what we noticed that was when we were using our iOS devices, we were connected to one of the Bluetooth low energy devices, which was TA, from one app, and then we switched over to another app, and we could connect it to a different device, and the connection was maintained between the old app and the old devices. So yeah, we can connect to multiple Bluetooth low energy devices from one smartphone at the same time. The second question that seems to get a lot of upvotes here is, are the updates in BLE 4.2 available through a firmware or a hardware upgrade? So the hardware does not need to change. The hardware can remain the same. We can update the firmware for 4.1 as well as 4.2 without making any kind of changes in the hardware. So do we have a separate hardware for BLE apart from the usual one that we have on our phone? This is the next question that has been asked. So yes, so there are three kinds of devices. The first one is called the Classic, which is Bluetooth, the earlier version of Bluetooth. The second one is called the Dual Mode, which supports Bluetooth Low Energy as well as BLE. And the third one is only Low Energy, which supports only Bluetooth Low Energy. So in your any given smartphone, what we have is the Dual Mode Bluetooth Low Energy. The Dual Mode Bluetooth hardware, which supports the Bluetooth Classic as well as Bluetooth Low Energy. Okay, do we have a separate hardware? Okay. How many the updates? I don't realize if this is a question or a statement. Are we sending TCP/IP packets or the physical layer instead of Bluetooth packets? No, so we are not sending TCP/IP packets, but what we are doing is basically to make it easy for the lower level protocols to understand the TCP/IP packets without doing much processing on them. So we want the hardware to do a lot less processing to understand the TCP/IP packets. That's why we have this new IPSP profile. All right, so I think I've answered most of the questions here. I think I've answered all the questions. If you guys have any feedback, please leave it in the comments on Google Plus or YouTube. We will be, based on the comments and the feedback that we receive, we'll probably schedule one more hangout to talk more about TA and the features that TA specifically has. Any more questions, or I'm going to call it the end of the webinar. All right, I guess I'm going to, okay, so the link for the presentation has been shared on the showcase. I'll be adding that to the comments on Google Plus and YouTube as well. Thanks everyone for joining in today. See you guys soon. Thank you.